Suppose that several high school students were surveyed about their favorite breakfast beverage, milk or orange juice, as well as if they were seniors or juniors, and the information has been organized into the following Venn diagram. Conditional statements can be written to answer general probability questions and make simple observations just by using the correct regions in the Venn diagram. For example, a question could ask, how many seniors chose milk as their favorite breakfast beverage? The answer would be 9. It is the region that is overlapped by both milk and seniors. What is the probability that a junior will prefer milk? This is a conditional probability. They're asking, given a person is a junior, what is the probability that they will choose milk as their favorite beverage? In probability notation, that looks like this. Notice that the 26 total juniors come from the 15 juniors within the milk circle, plus the 11 outside both the senior and milk circles, which means these are the juniors who prefer orange juice. Out of all those surveyed, what is the probability that a student prefers orange juice? This is not a conditional statement. It is just a basic probability question. So, the probability of a student liking orange juice is 29 out of 53. The 29 comes from the 18 plus 11 outside the milk circle, and the 53 is the total of all students surveyed. In today's lesson, favorite flavors, different representations were related, such as two-way tables, tree diagrams, and Venn diagrams, and they were used to create probability statements such as the ones given in the Ready section. To create a two-way table, notice that the two characteristics are the information gathered from each person surveyed. In this case, they are the grade and favorite breakfast beverage. These will be the categories for the rows and columns in the two-way table. Now, fill in the information given from the Venn diagram. And finally, find the sums of the rows and columns to fill in the missing information. The two-way table can be used to write conditional statements such as, the probability that a senior chose milk as their favorite beverage is 9 out of 27. Whereas the probability that a person who chose milk is a senior is 9 out of 24. Basic probabilities were introduced in previous mathematics courses. In those courses, it was learned that the probability that an event will occur is the number of times the specific event occurs out of the total number of events. In probability notation, it's written like this. Notice that probability is written as a fraction of the form part over whole. In order to change a fraction to a decimal, divide the numerator by the denominator. To convert a decimal to a percent, multiply by 100. Here's an example. Find the decimal and percentage equivalent of 7/8. Divide 7 by 8 to get 0.875. And multiplying the decimal representation by 100 gives the equivalent percentage of 87.5%. A related method used to find basic probabilities is to set up proportional statements. Notice that for each relationship, the following proportion statement can be used. The probability of event A occurring is equivalent to the percentage that event A occurs divided by 100. And more generally, this can be written as part over whole is equal to percentage divided by 100. Using this equation, fill in the known values and then solve the equation for the unknown value. Here's an example. What is 43% of 200? Use the proportion from the slide before and fill in the known values to get the part divided by 200 is equal to 43% divided by 100. Notice that 200 is the whole. The problem is to figure out the portion of 200 that is 43%. So 200 is the total and the unknown value is the part. Since it is an unknown value, replace it with a variable. To solve the proportion, get a common denominator. To do this, multiply by a form of the number 1 on both sides of the equation. One way to do this is to multiply the left side of the equation by 100 over 100 and the right side of the equation by 200 over 200. This produces the proportion 100x divided by 20,000 is equal to 8,600 divided by 20,000. Since the denominators are equal, then the numerators must be equal, so it follows that 100x is equal to 8,600. Solving for x by dividing both sides by 100 gives that x is equal to 86. As another hint for this section of the assignment, recall that of in mathematics often means to multiply. So to find 1/3 of 1/4, multiply 1/3 and 1/4 together to find the answer, which in this case would be 1/12.